Okay. This might be where your problem of the day is coming from. Okay? So, there's basically two things that we need to know. One, for absolute value inequalities of the form, the absolute value of some algebraic expression is less than a number. Again, this is an algebraic expression. This is a number. Well, what do we do with the equation? We broke it up into two different things, right? We're going to do the same thing with an inequality, but we have to be a little bit more careful with our language. Okay? If the absolute value of a number is, or the absolute value of an expression is less than a number, then this is equivalent to the compound inequality. That's why we learned that before we learned this. Negative k is less than your expression is less than a positive k. So I'm going to circle that in red. The next one I'll do in blue. What kind of compound inequality is this? Connected with an and or an or? An and, because it's this double inequality, right? Now the next thing that we need to know, for absolute value inequalities of the form, the absolute value of some expression is bigger than some number, or it could be bigger than or equal to. Then this is equivalent to the compound inequality. X is bigger than or equal to the positive piece, or X is less than or equal to the negative. Okay, now you have to be really careful with reading these things and knowing your signs. Okay. For one, this is a compound inequality with and, so when you graph it, what's the operation that we're going to do with our graph? And is union or intersection? Intersection. When you graph this one, it's an or, so it's going to be a union. Okay, so that's one thing. The other thing is you have to look at the absolute value is less than or something, you've got to use this rule. If the absolute value is bigger than something, you've got to use this rule. And then finally, the last thing that you need to look at is for this one, when the absolute value is bigger than some number, you keep it, you drop the absolute value and you keep it bigger than the positive part, but then you're going to make it less than the negative part. Okay, you don't want to get your negative signs mixed up here. Okay, so let's just do some examples. And I want to try to keep this handy. I'll be referring to that. This is section 4.3. Well, let's just look at the absolute value of x is less than 4. Okay, so which one of these forms, 1 or 2, am I going to be using? 1, because I've got the absolute value is less than something. So then using my rule here, I can rewrite this as negative 4 is less than x is less than 4. And we're pretty much done. If we want to break it up into two different ones, we can, but we don't have to. Here, what are we saying about x? X is between the two endpoints, -4 and 4. Does it include the endpoints? No. So it's going to be just that. Or to graph it. Interval notation. -4 is my left endpoint, open. 4 is my right endpoint, open. Any questions? And now let's look at what if it were the other way around? The absolute value of x is bigger than 4. What's the rule that I want to use? Sorry. The blue one or the red one? The bottom one or the top one? So I'm talking about absolute value of x is bigger than 4. Does it look like that? Yeah, the second one, this one. Okay, so using that rule, I have x is bigger than 4. This is the rule that I'm using. Or x is less than 4, a -4. I should have done this one in red, actually, and this one in blue. Okay, what does this look like? There's a -4, there's a 4. X is bigger than 4. So it does not include 4, but it's going to be bigger. So open this way, shade it this way. X is less than or equal to less than a -4, so it does not include the 4. I'm going to shade it this way. Okay, now what's the union of these? That's what OR means, again, is union, right? So what's our answer? What's our solution or our interval? What's this interval? -infinity to a -4. And then union, gluing together this one. Union with 4 to positive infinity. Now look at your two graphs. Here the absolute value is smaller than a number. What kind of answer did we get? Just one interval, right? Just this one piece. When we said the absolute value is bigger than a number, we got two pieces going off to the sides. Okay, that's typical. Okay, so keep these examples handy and the rules. You will definitely need to have these rules known and memorized, these formulas. Okay? We'll do a few more examples. Any questions right now? Let's see. How about absolute value of 3x minus 1 is less than or equal to 10. And the absolute value of 3x minus 1 is greater than 10. So what is this one going to be? I want to rewrite it. Remember, my rule says if I have an absolute value inequality of this form, then it's equivalent to this. So the way for me to solve it is to write it this way, and then I can solve it. So what is my x? Remember, this x is an algebraic expression. What's my x in this problem? 3x minus 1. Now, what's my k? Positive 10. So I'm going to stick this 3x minus 1 between a negative 10 and the positive 10. Now notice here, in this example, it was strictly less than, did not have the or equals to. That means when I rewrote it in this form, I kept it that way. In this example, I have the or equal to part. So when I write it in this form, I keep that or equal part. Same thing in this example. Can you guys solve this? Got it? Add 1. Negative 9 is less than or equal to 3x is less than or equal to 11. Divide by 3. Negative 3 is less than or equal to x is less than or equal to 11 over 3. So negative 3, 11 over 3, including the endpoints. Looks like that. Negative 3, 11 over 3. Is this a fair problem of the day? I've got an example just like it above it. And I've got an example that is a little similar over here. Maybe I'll get you started on it. Using my rule, I've got the absolute value of something is bigger than a number. So I'm going to write these two inequalities. So I have 3x minus 1 is bigger than 10, or 3x minus 1 is what? Less than or negative 10. Okay, take your time. Everything we've done today has been leading up to something like this. When we started with compound inequalities, that's what we were working on.